Hey, EE1520 student. I came to Taipei. I'm in Taipei right now. I came to Taipei yesterday for evening meeting, and then today I have a meeting later at NSTC. So it's hard for me to cover both activity and then come back to Tainan. So I have to uh, remote record this lecture and to cover, and hopefully TA is there to answer some of your questions that you might have. So today we're going to talk about CPP09. And let me conceptually explain what CPP09 is. CPP09 is a concept about, sometimes I call it shadow object, or sometimes I call it proxy object. So in CPP07, what we did is what we call a remote object, means that this object is remotely at one of the server, and I need to know both the object I would like to contact, and second, I need to know the URL of the object. That means I have to find out exactly where it is in order for me to contact this object. Of course, this is very popular in object-oriented programming language that in a distributed sense that you have to know the where is the resource. That's why it's called URL. It is in this under this URL, so you actually contact, and then you contact this object to invoke a method, and then basically you done your job in this kind of remote setting. But if you think deeply, this is one lesson for programming. A very important principle of software engineer is that how do you separate the requirement about the problem such that a programmer will need to worry less than necessary? Uh, then that's the concept of shadow object and remote object. Essentially, what we did at the end of the class, you will realize what we separate in um, proxy object versus the concept of remote object we talked about last time. The key thing is that the programmer doesn't have to know where the object is. So essentially, it's interesting. I want to contact an object. Um, I should just worry about maybe something like object identifier, but I don't know exactly where the object is. And then I can actually write my program, focus on my interaction with the object without worry about where it is. By the way, this concept has been there for a while. I mean, for example, I'm using Google, for example, YouTube to kind of distribute the content. But do I need to know exactly where YouTube store the file? I know the name, the ID is www.youtube. Whatever. In reality, the the exact location of the server storing the bits and byte is sometime which I don't need to know or I cannot know exactly. I mean, for example, a typical service like Google or Facebook or Amazon, they typically have a multiple site. So essentially, they duplicate the same thing in multiple site. And then exactly which one you will be using is usually depending on the network performance. I mean, which one is closest to where you are, then you get access to that particular copy of the content. That's the concept of content network distribution. So they worry about, well, the network performance is going to determining where you're going to retrieve the content. But that doesn't have to be the only reason you need to determine where that object is. It might be security, it might be some other reason, such as a firewall, and then you decide how you're going to retrieve the object. But from the programmer perspective, that they usually don't need to worry about that. Hopefully, they don't need to worry about that. And today I'm going to demonstrate how to use this concept called shadow object that you will be able to handle this. Okay. All right. So let's look at the idea. The idea, I have a client and the server. So the idea of a shadow object is that what my real goal is try to access this object. I mean, if I don't have this particular circle over here, I write a program called RO client, and the RO client is using remote procedure call directly call to the RO server. And inside RO server, I have this object identifier 1001, such that I directly call a method on a object that's currently live on the RO server. Okay, so there are two things. I know which object I would like to contact. I also know exactly where that object is. Okay, this is necessary at some point, but this is somewhat is not necessarily uh, um, the programmer's responsibility. So they usually have some service is helping you to determine where exactly a location, where is the location of particular resource. For example, DNS, domain name service. It basically provide a lot of trick for you to not necessarily know exactly what's the IP address that map to a particular UI, a particular domain name. Okay, so we're going to do something similar, but what we're going to show you is that, okay, I'm actually going to create another object. In this case, in the scenario of shadow object, I actually create two objects. So one object is a real object that's remote, but the other object is called proxy object or shadow object, which is actually reside in the PO client. P stands for proxy. Okay, proxy object client, which is a terminology we use for CPP09. So the shadow object representing the remote object is actually in the same program with the client, which means that this object, shadow object, is actually in PO client. And then when the PO client really want to interact with the remote object, is actually interact with the shadow, with the proxy, and such that whenever you interact with this, then it will be indirectly go over there to interact with the real object. So in some sense, if you're familiar with the concept called digital twin, this is similar to digital twin. That means your local visualization is interact with a local object, but that local object has information for you to communicate with the remote object. So you actually communicate with this and without worry about how to get to the remote. So that's a concept. Okay. So this is a concept, shadow, remote, or sometimes you can call it digital twin. That's well, digital twin, of course, is much, much more complicated than this scenario, but this is kind of the simplest way of implementing a digital twin. Okay. Okay, so now we have a scenario. You really have a two object. One is the real one is the shadow. By the way, I can extend this scenario very easily with multiple um, layer of shadow. That means a shadow object number one that's interacting with the PO client and is actually pointing to another shadow on maybe another program. And that shadow will also redelegate to maybe yet another shadow or the real object. So the software architecture has multiple level about how you can identify the exact location of the real object you would like to communicate. But the first hop, the client, which initiate the contact with the remote, is actually only deal with the first level shadow object. Okay, so today we're going to learn not just the concept of shadow object, but how to realize this concept in C++. In fact, I will argue that this is one of the most important application for polymorphism or virtual function. That's actually an inheritance in the design of the C++ programming language. Okay, so before I talk about that, I want to tell you um, okay, I probably should say this earlier that this is a few things. Okay, so we're talking about if you learn about CPP09, you essentially know how to do distributed programming, and you know how to do what we call a virtualization or abstraction about some remote resources. And you know that this particular abstraction can be dynamics, can introduce multi-layer of interaction, and also related to that is mobility, means that the object is actually changing its location. Part of the reason that we have to do this is that we don't know exactly where that particular object is in certain application. I mean, for example, if you have some of the machine that's like a drone that might be move around, and at one point it's actually connect to one of the server, and you don't know what it is, and therefore because the real object has the issue of mobility, then we need to some kind of tracking for us to know where it is, and then we can use shadow object to eventually connect it to that. I mean, there is a lots of interesting application related to mobility and tracking. Once you know today's PO client and PO server, which is CPP09, that you will realize that you can do very elegant programming to solve a huge class of this kind of distributed programming issue. Okay, so before I show you the code, I'm actually going to also show you the inheritance hierarchy in our example. So, so this is the inheritance hierarchy we're going to see in CPP09. So previously we have GPS as a base class. And then we have a label GPS as a derived class, which is the main issue about this label GPS is introduce a label. Okay, so that's what we already know. And now we are going to introduce a new class called shadow GPS. So it's also a derived class from the base class GPS. Okay, this is going to be a very interesting design. So, so we introduce another class, which is through the GPS. By the way, it has to be. It has to be in order to get this the proxy object to work. And then it can actually help you to determine this actually proxy. So we're going to learn how this three things going to put together. But let's first take a look at the shadow GPS because you should be familiar with GPS and label GPS went through the previous lecture. So I'm going to focus on shadow GPS first. Okay, I'm going to, where's my, I just realized I didn't share the screen earlier. Wow. I hope you can see my screen right now. I was talking about the shadow object with this concept of PO client, and I was talking about the the inheritance hierarchy with GPS and shadow GPS. Okay, now I'm going to here. Here is what I'm going to do. Okay, let me make a clean and make. Okay, so I'm going to run server and I'm going to run client. Okay, so you can see that I'm actually come over here to execute this program, and it basically similar to CPP08 in terms of the interaction between the PO client and PO server. By the way, the all the source code about CPP07, CPP08, CPP09 are all under my GitHub directory. So you should download and then play around yourself. Okay, so at this level, you didn't see the difference between these two. But let's take a look at the program itself. Okay, let's look at the client program. Okay, this part is similar to what you have seen before. Okay. Okay, now you see I have a bunch of objects. Okay, take a look at this part. Yeah, that's fine. Okay, so let me actually tell you what I did here. Over here, I create two real object. I create this two real object. They're both labeled GPS, and I create one shadow object, which is when I create a shadow object, I actually provide the URL of the real object that represented by the shadow and the class of label GPS and 1001. That's basically say, hey, this shadow object representing a remote object and under the class of label GPS, and the object ID is 1001. So I'm essentially creating a shadow object. I call the shadow object 1001. And I have the other two objects called real object, real one and real two. Okay, here's a trick. I actually um, store another pointer called GPS PTR. So you can think about anything after this line is a real programming. But before this, I will call it its configuration. It's configuration about the information about where that object is. Okay. So look at this. I actually declare another pointer called GPSDD, and I declare another pointer called label GPS star. I basically store the value of the pointer pointing at the shadow object. Okay, so right now I can put the pointer to be the shadow object, or I can put the pointer to be real one or real two. It doesn't matter. Okay, but now what I did is that okay, don't worry about this one. This one is something I did some kind of casting, not just casting, but do some kind of overwriting, and such that I have this one issue. But I want to actually mention about this part. This part is a code I really want to do. Okay. So this piece of line, I actually make a function call called set GPS label. I call a function called GPS, very similar to what I did. Okay, but I actually go to an object, which is this object is a label GPS pointer. I actually call a function called set GPS label such that I can replace the label. Okay, however, there is an interesting part is that when I invoke this object, I'm using this pointer, okay, label GPS pointer, and then this. By the way, this is interesting. You probably, I should probably write this way. There's two way of writing this line of code. The other way to write this is I can do this. Because it's a pointer, I can do this. Okay, you see that? The difference between these two is essentially using a notation about a pointer notation or using a dot notation. I can actually just um, um, put the star here, make it an object instead of the pointer, and then the whole thing I can use the dot notation. So I'm going to leave it here just to let you know they're the same. Okay, so this line you might not. The first time you look at this, you probably don't realize what it really indicate. But I want to go a little bit slow. I want to convey this information because this is the key concept, which is not so easy to understand about why this particular way of writing it is significant. I mean, previously, I okay, let me do another way because I know that label GPS is actually shadow object one, right? Shadow object 001. So of course, um, uh, if you're not very careful, that the other way to write this is actually, I hope you agree with me, is shadow. What do I call that one? Shadow object 1001. I can do this as well, right? I can do this, I can do this, I can do this, or I can do this. Okay, I can do any one of this to do the to convey the object. Okay, okay. There is a first issue that this line you might have a compiler error. Okay, the reason you might got compiler error if you want to write this way. Okay, I'm actually storing the pointer into label GPS pointer, and then I'm actually calling set GPS signal. What is the data type for shadow object 1001? Is shadow object. If you look at the inheritance hierarchy, it is inheriting from GPS. It's not inheriting from label GPS. What does that mean? That means it doesn't have set label GPS function. So using to directly call using the shadow object 1001, you might encounter this problem because of the inheritance relationship. So you cannot do that directly. But there is another reason about this, about why not doing this, is that we might change the relationship. We might modify the relation between shadow object 1001 and the label GPS PTR. Okay, the relationship between shadow, by the way, this is very important. I hope you listen very carefully. I'm saying that there is a relationship between shadow object 1001 and the label GPS PTR through this particular line of code. Remember, we have this line of code here. Earlier, I'm going to move it over here so you understand. So this was the relationship. I kind of bind the address of shadow object 1001 into the pointer to a label GPS object. Okay, I did that such that these two are actually equivalent. That's the relationship, but that relationship might change because I show you another example here. I might actually have this line somewhere in between. I might actually do this. Before you make this, you reach this particular line, right? I can change the code and I can change back as well. So there might be a lot of things happening before the object was created until the moment you need to really make the call. And therefore, in this case, that is actually not going to predictable about when you're doing shadow object 1001. It's still exactly the things you would like to do. So this line is more general. So this line is more general means that I just need to worry about it's a label GPS PTR, and then it might be a real object, it might be a remote object, I don't know. But the programmer doesn't need to know. The programmer just need to know, hey, I know there is a pointer called label GPS PTR. That's the object I want to interact with. So from the programmer's perspective, I only need to worry about the interaction between my program and label GPS pointer or the object being pointed by the label GPS pointer. And okay, that's all I care. As a programmer, in fact, any object-oriented programmer, you want to interact with object. I'm going to write a program to call a function to modify the attribute. So that's all I care. I want to actually dealing with this object without need to know exactly where the object is. That object may be on your computer under this program. That object may be on this computer but on the other program, or this object might be in France or Russia. That there is or there are servers that's actually hosting your object. So that's the resource placement issue. But as a programmer, I don't need to worry about that. The programmer, I only need to worry about, hey, I'm dealing with this object and all the complexity about networking, about where exactly it is, and or about the mobility of the object is not my business. As a programmer, I shouldn't need to worry about. That's a separation. That's a very important and clever concept to implement large complex system such that you separate the issue. The programmer only need to deal with this particular object called label GPS PTR. So I'm using a very simple example, but this example indicate a very powerful tool for you to have a easily separate system architecture for you to implement a very complicated system. In fact, you can think about all the distributed system today is essentially based on this concept. Okay, All right. So now this is a program. If you take a look at this program, starting from this point, starting from this point, it's essentially really nothing you need to worry about exactly where the object is. I'm just making a call and then do such thing. And the next part of the program is the same thing. I'm actually calling another function called GPS PTR, uh, dump to JSON. Okay, that's again, I don't know where is GPS underscore PTR, but I know it's a GPS object. And therefore, I'm actually interact with that object and I don't care about anything else. Okay. So that's the important lesson that we need to know about um, um, proxy object or shadow object. Okay, so now we're going to start take a look at the program itself. So of course, we have to look at the first program. We have to take a look is shadow GPS. Do I have this program here? Yes, I do have it. Okay, so I have this program called Shadow GPS. Oh, wait a minute. Interesting. I actually make it such that it's inheriting from label GPS. Huh, interesting. Can I make it differently? I think I have a two version. Let's start it with this. Okay, let's start it with this version first. Let's try to modify later. So in this program, what I did is, okay, I have to update this a little bit. So the inheritance hierarchy is actually looks like this. Okay, so shadow GPS inherited from label GPS inherited from GPS. Okay, I can actually modify to reflect a different way of implementing this. Okay, and now let's take a look at shadow GPS. It has an inheritance relationship, and then it will get all the longitude, latitude, and label from whatever. And the thing is that what it does is that it has a three argument that's actually necessary for you to identify. So you can think about the detail about how to allocate, how to find where the object is going to be hiding inside the shadow. So the proxy will need to know. Okay, programmer doesn't need to know, but the shadow need to know. So therefore, we have a three argument, which is host URL, class ID, and object ID. And then I still have a constructor. I still have this two virtual function, set GPS label and dump to JSON. Okay, that's the definition of the shadow GPS. So with this definition, let's actually go back to PO client. And inside the PO client, you see that I'm actually creating a object. But okay, one thing I should know is that this is a constructor. So one thing I should tell you, remember the constructor take a three argument, URL, class, and object ID. So if you take a look at the program, even though it's inheriting from label GPS, it doesn't need to set the um, um, it doesn't need to set the latitude, longitude, and label. It just need to set this three argument, which is host URL, class ID, and the object ID. Okay, you need to just set those three things and you're done. Okay, so let's take a look at the okay, now I'm actually looking at the shadow GPS.cpp. So first, you have to take care of the oh, by the way, now you see I'm actually include PO client is over here. Okay. This is a one big difference. Okay, I have over here I have a line which is related to PO client. Let me try to get rid of this too. I don't want this to be part of this. And I get rid of that. And let's try to make. Oh, I need JSON. Oh, that's why I need JSON. Okay, I'm going to modify this because I don't need JSON either. So I'm sorry, I should clean up this a little bit. Okay, so I will just change to be STD. Is that lowercase? Let me check. Yeah, lowercase. I will talk about exceptional handling a little bit after this topic, but right now I'm using the standard exception. Okay, I don't need to use the JSON. This is another one. I need to get rid of this because I get rid of all the JSON RPC stuff. And I get rid of this. Okay, you see that? I actually get rid of that. So essentially, the programmer who never wrote PO client, he doesn't have to know all the JSON RPC related stuff because all he care is interacting with the object and without knowing where it is. Without knowing that, it's actually using JSON RPC because I'm not really don't know. Programmer doesn't have to know. So I have to get rid of that and it still work. Okay. So now we can go back to take a look at the look at shadow GPS. So you see, when I remove those information from the PO client.cpp, I have to place it somewhere. And those things we place is actually under the program shadow GPS.cpp. So you can see that I removed that portion of the code into a different piece of code, which is only handle the shadow. That's exactly what we want. Okay. So over here, I have those few lines I just comment out. And then I have the constructor, which is just initiate host URL, class ID, and object ID. And then I have to deal with the function, for example, dump to JSON. Yeah, let's take a break here, and then we'll continue.